On the screen we have a few long coupled pumps installed within a plant room. Can you discuss the rubber bellow installation on the suction and discharge of the pump?
Okay, well, looking at this particular diagram, we've got a situation where we've got an elbow going straight into the pump, which is not great. I would prefer to see a suction diffuser there, which cuts down the bend. I'm happy with this installation for the flexible connection because it avoids any trapped air with the flexible connector at the pump suction.
Why is that, Keith?
Well, there's a potential for an air trap. This has not got a parallel path through the rubber, okay? It's domed. That's what gives you the flexibility, the fact that that rubber is domed. So there's a potential for a little bit of an air bubble to get trapped in that connector.
If someone was to install a rubber bellow on the suction side horizontally to the path of the suction, would it be best to install an eccentric after the rubber bellow or before?
Yeah, I would probably install it before the eccentric rather than after. It gives you a better flow path into the suction. But it's based on experience. What has worked for you in the past? You know, you can get different designs of flexible connectors. They're not always that rubber connector. You can get some that have got a parallel rubber and they're covered with some sort of stainless steel mesh. So look at the piece of equipment that you're playing with and make the best decision that you can to give you good suction conditions. So what are the things to avoid in suction? You want the suction line to be as straight as possible, as few bends as possible, as large as possible, and with no air traps. Those are the things that you should be looking for in good suction design. And that's the same whatever type of equipment you happen to be using. But with suction connections, you always want to have a flat top eccentric reducer.
On the screen we have a long coupled pump installation. Can you give your thoughts on the installation and how they've reduced the pipework and how they've installed the suction diffuser?
Sure. Look, there's nothing basically wrong with the installation. From the perspective of the suction side, there's no problem to have this little branch piece in between the suction diffuser and the pump flange. I mean, that's obviously matching the flanges, so there's no potential for air traps. On the discharge side, obviously they've had to match the pipe eventually down to the suction discharge flange, so they really don't have any option. I would have preferred to use a pre-manufactured concentric reducer there. It would look prettier. I mean, the problem with this installation, it doesn't look nice. And most people, when they walk into a plant room, actually want to see reasonably attractive equipment in the plant room. That's not pretty, but it's functional. So the guy probably has met the requirements from a functionality point of view, but wouldn't get too many high marks for his presentation.
Follow-up question, Keith. The immediate section on the discharge, is it problematic? In the past, we found issues where there was a lot of noise on the discharge end of the pump, similar to this install.
Yeah, look, I would have preferred from a pipework point of view to have this eccentric reducer much closer to the flange, okay? Because what are you getting here? You're getting high, if this is a two-pole pump, I don't know, but if it's a two-pole pump, you've got very high velocities there, probably 10 to 15 metres a second. Whereas in this, you've probably got 3 to 5 metres a second. So there will be a much lower noise level generated by the hydraulic flow through the pipework in here compared to here. So these are the sorts of things that there's nothing wrong with it, but it doesn't give you the best or the optimum operation, from my opinion.